Today we're going to build something really cool. We create a chatbot that interacts with PDF documents using Streamlit, and I'll guide you through every step. Let's dive right in. First, let's set up our workspace in the Google Colab. It's a fantastic platform that allows you to run the Python code directly in your browser, and it's completely free. We'll start by creating a new notebook. So this is the new notebook. Let me call it first GenAI demo. Next, we need to install Streamlit. Streamlit is a library that makes it easy to create interactive web apps. Install it with a simple pip command. Let me run that pip command. Install -q. Run this command and Streamlit will be installed in your Colab environment. Alright, let's create our first app. Let me create new file here. I'll call it GenAI1 Streamlit.py. Let's import Streamlit library. This is going to create a web page. I'll show you once we run it. We'll set a sidebar and then take that file to this object. Any uploaded file can be taken into this object as long as it is PDF. And then we need, this should be of type PDF. This code creates a sidebar for uploading PDF and a header for our chatbot. It's a basic setup, but it's a great start. Before we run the app, we need to get our local IP address. This is essential for accessing the app from a web browser. I ran this command to retrieve the local IP address. Now let's run the Streamlit app using the Streamlit run command. We'll also use a local tunnel to expose our app to internet, allowing us to access it from any device. You'll be prompted to say yes here. Click this link and you'll see a web page where you can you need to enter this local IP address as the password. Here I entered the tunnel password, which is our local IP address that we got earlier, and then submitted. Now we can see the page. ST is not defined. Let's see what it is. Okay, I think now it's updated the code to have ST there. Streamlit. Now again the same thing. Click on that link. You have to enter the password here, which is the IP address that you got earlier, and then you should be able to see the first Streamlit page. Here you can upload a file. Just I'm uploading some random file. Here I got a US Constitution PDF. I uploaded it there. Let's clear the logs here. I'll keep this IP address so that I have to use this in the future. Now let's update the program to extract text from the uploaded PDF. New file. I'll copy content from here. I'm going to import a PDF reader. Let's try add some comments here. Next we're going to extract the text. So now the utility to extract the content of the PDF file is ready. Let us run it. I'm expecting an error now, but I'll show you while I'm running the app. No module named PyPDF2 is there. So let us go back, stop this and clear the log. Let me run this command before running that code. Let us run this command to install PyPDF2. Now this should work. See, the content of the PDF file is extracted here. Now let's move on to chunking the text from the PDF. Chunking is important because it breaks down the large text into manageable pieces, which is essential for processing in natural language models. Let's copy the code from previous program and paste here. I'm going to add a text splitter here. Recursive text splitter is a library from LangChain. I'm going to put the separator as new line and chunk size as 1000. That is, we want to break the entire text into chunks of 1000 characters, and chunk overlap as 150 characters. Basically this says how much of the text overlap can be there between the previous chunk and the new chunk. Sometimes it may not be logical to just cut the string in the middle, so to give more context to the next chunk, we have to get some overlap content. Now we are chunking it and writing it into the file. Before running this program, Similar to how we have done here, we have to import some libraries. Looks like it is done successfully. Let me clear the logs, and I have to run this program that we just created. So I'm pasting the previous command. Now this new program name is chunk GenAI 3 chunks. I'll upload the US Constitution once again. I did a mistake here. I didn't comment the previous text, the text that was previously written here before chunking, so everything would be printed. So in this code, the recursive character text splitter breaks down the text into chunks of 1000 characters each, with 150 characters overlap between chunks. This is particularly useful when preparing the text for tasks like embedding or vectorization. You can see the chunk with numbers here. Now let's write the program to generate embeddings and create vector store. Embeddings are the numerical representation of the textual data. We have to create embeddings, create vector stores. Embeddings are then stored in FAISS vector store, which allows for efficient similarity searches for any given query that we enter. Let's see how it works. Let me copy the code from the previous program
and comment this writing of the chunks. Now we have to create the embeddings.
Oh yeah, OpenAI embeddings we have to import.
Let us import the FAISS vector store also.
We have to enter a OpenAI API. Let's create that parameter here. We have to enter our OpenAI key here. Let's Google how to get this OpenAI key. This is the OpenAI key page where I can create new secret. Going to create a secret. I'm going to copy it. Now I'll done. The copied key should be placed here in my program, OpenAI key. Now let's compile and see if this has any problem. Oh, before running this, we need to import some libraries, right? Here we introduce new library called LangChain community. Now the LangChain community library is installed. Now I have to install few more libraries here. All these three libraries are installed. I came to know that these libraries are required by running this program before. Now let's run the program that we created to make sure there are no issues with it. Of course, we wouldn't be able to see any errors, any output there, because we're not printing anything. I want to make sure this program runs without any problem, though we have given the API key to create the vectors. So what happened right now is the file that we uploaded, constitutionusa.pdf, that was chunked, that was split into text, and it was chunked, and the chunk, the embeddings were created, and the chunks and the embeddings are saved in the vector store. These embeddings are stored in the FAISS vector store, which allows for efficient similarity searches. Let's take it a step further by performing a similarity search. This will allow us to query the vector store with a question and retrieve the most relevant text chunks. I'll copy content from the previous program. Let me paste it here. In this program, we're going to first get the user question. We can add a text box in the Streamlit. And then we can write the code, write the similarity search results. Let's see how we can get the user question. This is the text box. Here is the user question. Now let's see if user question exists. We can query on the vector store. You can do similarity search on the vector store with that user question. And then once we get that, we'll write it to the UI. Let's see what search results come up out of this vector store. This may not be a very user-friendly result, but we'll still see something, some chunks of data that matches the query. I'm uploading the file now, and then ask the question. The question I have is, how many senators can each state of USA have? So there are chunks identified here that has data related to my question, but it's not very friendly. These are just chunks extracted from the PDF file by looking into the vector store. Finally, let's put everything together by using OpenAI's language model to generate answers based on the results from our similarity searches. Code from the previous one, paste it here. Here I'm going to define LLM. Okay, in order to use chat OpenAI, I have to import that. I should also import load QA chain library. This is the OpenAI API key we entered here. Temperature equal to 0. Basically, we can, if we give high temperatures, we can give something like 0.5, 1, 2, and different numbers here, but there the results may vary. The results may go outside your document scope. So it depends on your tuning mechanism. Like you can just do trial and errors and see with different temperatures how you're getting the results and tune it accordingly. Max tokens are 1000. If you get more tokens, you can always you'll be feeding more to the OpenAI system, and you'll be charged more, obviously. So So here we have to give the model name here. This is something we have to find out what is our model name. This we can identify by searching for model name online. The best page that I want to see is the pricing page, where every model and the corresponding prices are given. Choose something 3.5 GPT 3.5 turbo. Also remember, when you run this program, you need to have some money credited to your OpenAI account. Let me show you mine. Here I have $9.63 in my account. Of course, we'll be using few cents while running this program. It's not free, however, it's not very expensive to do some testing. Now we have to change the questions and the document to match the generated output. In this final step, the script uses OpenAI's GPT 3.5 Turbo model to answer the questions based on the relevant document chunks found in our similarity search. The approach ensures that the chatbot provides accurate and contextually appropriate response. I'll comment this right. I didn't align this properly. All this comes under the user question. Yeah. Here you can see the result from the LLM. All the chunks and the question were passed to the LLM and we got an appropriate response. And that's it. We have successfully built a chatbot that interacts with the PDF documents, leveraging the power of Streamlit and OpenAI. If you found this tutorial helpful, please give it a thumbs up, subscribe to the channel, and let me know in the comments what you would like to see next.